Now, VPC peering allows and 1099.00. Choose VPC1 as the acceptor. So we can double check the seeders. We got 10.000. And 1099.00. We'll create the connection and click OK. So you'll see here that it's pending acceptance. And because I own both VPCs, I can go ahead and approve this right now. If another company or another account holder owned the other VPC, then you would have to wait for them to accept it. But I can accept it right now. And we see that the peering connection is active and it accept it. But I can accept it right now. And we see that the peering connection is active. To open. So we'll just leave that as it is and we'll launch and use the peering key. So we have the same key for both instances. And we'll view them and we'll give this a name of that'll be Bastion VPC1, and we can tell it's in VPC1 because it's in 1099 1.6. 1099 is this VPC here. Now I'm going to grab the public IP of this Bastion host, and I'm going to go over to the terminal now. First thing I need to do is change the permissions on our new key.
You have 15 minutes remaining.
All right. Now I'm going to set up SSH forwarding. Now I need to add the identity. All right, now I'm going to SSH to the first bastion, this bastion right here. And I'm going to do this with a capital A so that it will maintain the key so that we can pass it to the next instance. And paste the public IP. And we're connected, 1099.1.6. And now we can cross this connection right here to this bastion, which only has a private IP address. So I need to capture that address right now. 10.0.0.34, that's what I'm going to SSH to. And on the second part of this, I need no identity tags on the SSH statement. And we're connected. So this connection will allow us to privately access data in VPC2. Could be very sensitive data as to the requirements that have been passed down to us. And so our applications need to be able to communicate with that data without going over the internet. This is where VPC peering is so helpful. And again, there is a throughput advantage because you're not having to rely on the variable throughput of the internet between your VPCs. This learning activity is complete.
Button. For the subnet setting, be sure that we choose the subnet called private. You can see the name here. Once you've selected that, click the Review and Launch button, and notice that in the security group settings, the defaults have allowed SSH access. We'll use this again just for demonstration purposes in a moment. Click the Launch button, and we'll create a new key pair. I'll call mine NAT Lab Key Pair. I'd suggest doing the same just to follow along. Now, since a private subnet does not have an internet gateway attached, the instance we just created within it cannot interact with the outside world. This can be beneficial from a security standpoint because if there's no way to connect to it over the internet, the chances of unauthorized access have been decreased. If the instance itself can't access the internet, however, it's easy to realize some problems. For example, the instance may need to download security updates from the internet or download a file, etc. To demonstrate this problem, let's connect to the instance we just created via SSH and attempt to run sudo yum update, for instance. But because the instance is private, we'll need to create a new one on the public subnet so that we can connect through it. So let's go back and launch another t2.micro instance, again using the Amazon Linux AMI. This time for the subnet, we'll choose the public one. The rest of the default configuration is fine, so we can skip through. Again, note that the security group does allow SSH by default. We'll use that to connect in a moment. Click the Launch button and choose to use the existing key pair that we created earlier called NAT Lab Key Pair. Now, just as a reminder, we're using this public instance to connect to the private instance because they're in the same VPC. We cannot connect to the private instance directly from the internet. I'll use the connect option after selecting the public instance to grab my username and hostname to connect with terminal. So I'll just copy this and open a new terminal window. We'll navigate to our key pair file with CD. I'd put mine in the downloads directory, so I'll go there. And you can see that I do have it. Let's use chmod 400 and the name of the key pair to set the proper visibility. I'm going to add the key pair to my SSH agent so that we can connect cleanly from the public instance into the private instance without having to copy over the SSH key. So we'll use SSH add and the name of the key pair. Now we'll use the hostname and username that we copied a moment ago and connect with SSH. Be sure to use the A option when connecting. Accept the fingerprint, and we're now logged into the public instance. Now I'll go back to AWS and grab the information for my private instance. We'll use the connect button again, and I'll grab the username and hostname Excuse me. You have 15 minutes remaining. The private IP address of the private instance. I'll use SSHN, paste, accept a fingerprint, and our terminal now sits inside of the private instance. Now we can run something like sudo yum update to see that this instance has no access to the outside internet. This will time out in a moment. If we go up, you can see that this did indeed time out. This is because it is not within a subnet that's connected to an internet gateway. It has no access to the outside internet. The only way we've connected right now is through the public instance and then connecting locally. So let's fix this problem and allow this private instance to access the internet via a NAT gateway. Head back to AWS and we'll go to the VPC dashboard and click the NAT gateways link to the left. Use the big blue button to create a new NAT gateway. And we'll want this one to be assigned to the public subnet so that this gateway can access the public internet. So we'll choose the public option. We don't currently have an elastic IP, so I'll create one with this button here. It will create and insert the allocation ID, and then we'll create it. From here, I can use the Edit Route Tables option to set up the remaining configuration. A quick note, we see that this route table has one subnet explicitly associated to it. We can see that this one is indeed the one that has the internet gateway attached and has been associated with the public subnet. The subnets listed below, in our case just the private one, have been implicitly associated with the main route table. So our private one has been associated implicitly to the main route table. We can find that one by looking at the main and finding that one. This is the main route table for this VPC. If we click it and go to routes, we can add a new route for our NAT gateway. Click edit and add another route. We'll do this to the open internet of all IP addresses 0.0.0.0/0. Click into the target and we'll choose the NAT. Click this and save the settings. Our NAT gateway will take some time to set up and we can check its current status by going back to the NAT gateways section. And we'll see that this is still pending. This can take some time to become available, so just sit back and use the refresh button on occasion. Once the status is available, go back to your terminal that's connected to the private instance and try rerunning sudo yum update. Because we've set up and properly configured the NAT gateway, we'll have no problems with this sudo yum update. It has access to the internet now and can pull in the required files. This does not change the fact that this is still a private subnet, meaning that I cannot connect to it directly from the internet. We still have that security benefit, but now I can have access to the internet to download security updates, other files, etc. I'm Davis Singler. Good luck moving forward.
Amazon Linux AMIs have this pre-installed, so we could just start with AWS configure. These access keys are also output on your lab page. And we're all set. So now if I do AWS S3 list buckets, I get both of my buckets that are available. And now I want to show you just real quick about the file name thing and why it's a hazard. And that's why, because anyone that can read the bucket, even if they don't have access to the files in the bucket, when they perform a list bucket, they can see these file names. Now, I'm logged in within an admin account right now, so I can see everything. But trust me, people that don't have rights to those files can still see the titles of the files themselves. So keep that in mind. So let's break this. I'm going to go to our VPC and I'm going to delete the NAT gateway. So now instances in our private subnets should not be able to get out. We'll give this just a moment. I'll be right back. Okay, we can see that the NAT gateway is deleted. And I'm going to go to route tables. And this is the route table associated with my 4 private subnets over here. And it's showing you that the NAT gateway route is a black hole now. So let's edit that and we'll just remove it. And we'll click Save. So now for our private subnets, there is no path to the internet. So let's go over here and try these commands again. We'll do AWS S3 list bucket. And it fails because to access this, we have to get out to the internet and then back into S3. So here's how we can do this securely. We can create an endpoint for S3 and place it in the Security Essentials VPC. And we're going to assign it to that route table that has the 4 private subnets. They're listed there. And we're not going to worry about the policy for now. Let's create the endpoint. And this can sometimes take a little bit because it's going to show up in this route table eventually. So let's go up here and look at it. And we have it here. And I'm going to pause the video because this could take a couple minutes to show up, and I'll be right back. Okay, and now the route is here. It's a private link route to our VPC endpoint target.